What if the cosmos never truly had a beginning and has instead been undergoing an endless series of rebirths? This line of inquiry leads us to the concept of a cosmic Big Bounce, a model where the universe doesn't originate from a single Big Bang, but perpetually rebounds, collapsing and re-emerging in an eternal cycle. In this striking vision, every conclusion is simply a fresh start, and the universe possesses no absolute origin point, only an infinite history recorded in the rhythm of its expansion and contraction. Have you ever considered the possibility that time isn't linear but cyclical? This perspective has been with humanity since antiquity, as cultures observed the predictable return of the seasons, the phases of the moon, and other repeating natural phenomena. From these observations, they inferred that life, and perhaps the universe itself, operates within a kind of unending loop. In contemporary cosmology, this ancient notion is revitalized through the Big Bounce theory, urging us to reconsider everything we know about the universe and its ultimate destiny.
The significance of the Big Bounce in modern cosmological discussions is undeniable. As scientists probe the depths of the universe, they grapple with fascinating questions, such as what transpired before the Big Bang. If the cosmos had no true inception, but has always existed in a cycle, reborn from its own remnants, then this idea not only challenges conventional theories, but also unveils countless new possibilities about our existence and the very fabric of time.
The Big Bounce framework also forces us to contemplate the ultimate fate of the cosmos. If everything moves in cycles, should we anticipate a renewal after the end? How might this influence our lives and our perception of history? Picture a universe that expands, then contracts, only to expand once more. A sequence that could have repeated an untold number of times. Each iteration might leave subtle traces that today's scientists are learning how to detect, turning this philosophical idea into a testable hypothesis. Another compelling facet of the Big Bounce is its potential link to phenomena we currently observe, like the universe's accelerating expansion. These observations might not be evidence of a single creation event, but could instead be just one chapter in a much larger narrative, a cycle that connects us to a past far more ancient than we can comprehend. Could it be that dark matter and dark energy, those elusive and enigmatic components of our universe, are actually the principal forces orchestrating this cosmic ballet? It's a concept that certainly invites profound contemplation. Furthermore, the Big Bounce introduces deep philosophical questions. If our universe is cyclical, what does that imply about the nature of time itself? Is time a limited commodity that eventually runs out, or does it exist in an eternal loop where all events recur? It's possible that this vision of a cosmic cycle could help us uncover a deeper significance in our own lives, transforming our view of them from isolated events into integral parts of a much more magnificent saga. The idea of a cyclical universe also resonates deeply with the spiritual and mythological traditions of diverse cultures. From the tenets of Hinduism to the concepts of Greek philosophy, the notion that everything born must eventually die and be reborn has been a persistent theme throughout human history. By investigating the Big Bounce, we can identify fascinating parallels between scientific thought and these age-old traditions, making one wonder if a more profound truth connects the principles of physics with philosophy. In this light, the Big Bounce theory serves as a bridge between scientific understanding and the overarching human story. The models surrounding this concept not only offer a structure for comprehending the universe, but also provide a space for meditating on our own existence and the part we play in the grand cosmic design. The implications are enormous and frequently mind-boggling. forcing us to confront some of the biggest questions we can ask. One question that naturally arises from the Big Bounce concerns the universe's ultimate destiny. Are we consigned to an infinite cycle of destruction and renewal, or is there some greater purpose behind this repetition? The premise that the universe endures an endless cycle suggests that, at some point, all events and experiences must repeat, sparking reflections on the nature of free will and the concept of predestination. Exploring the Big Bounce also motivates us to think about how science might continue to solve the universe's greatest riddles. As our comprehension of gravity, dark energy, and other cosmic forces advances, the picture of a cyclical universe may come into sharper focus. Every new theory and discovery inches us closer to understanding the intricate mechanics of how this immense cosmic cycle is structured. As we journey through the implications of the Big Bounce, we discover a universe teeming with mysteries and marvels. While modern cosmology equips us with the tools to investigate these ideas, it simultaneously serves as a humbling reminder of how much remains unknown. This quest for answers is a fundamental part of our human character, and the Big Bounce represents just one of many gateways we can open on this incredible intellectual adventure. Ultimately, the Big Bounce is far more than a mere concept in physics. It is an open invitation to explore the unknown. Every cycle we envision prompts new inquiries, sparks new theories, and deepens our understanding of both ourselves and the cosmos we inhabit. Our innate human curiosity, fueled by the desire to grasp our place in the universe, is what compels us to relentlessly push forward, searching for answers in every corner of reality. The Big Bounce theory did not materialize out of thin air. To grasp its significance, it's essential to examine its origins and the progression of ideas that have tried to decode the universe's mysteries. What came before our current models of the cosmos's beginning and structure? This question leads us directly to the renowned Big Bang theory, which proposes that the universe started expanding from an incredibly hot and dense singularity. But what came before that initial moment? Most people treat the Big Bang as the absolute origin, failing to consider that space and time could be far more intricate than that. For many years, the Big Bang theory has captured our imaginations and is bolstered by a wealth of evidence. This model, however, also presents some compelling questions. What if there was no absolute beginning for the universe? Could our perception of time just be one component of a much larger story? It is in this context that the Big Bounce appears as a captivating alternative, suggesting that the universe didn't just expand from a single point, but may be caught in a perpetual cycle of growth and collapse. To trace the intellectual lineage of the Big Bounce, it is helpful to look at the concepts of ancient philosophers and scientists, many of whom conceived of an eternal universe without a start or finish. This perspective was largely set aside for centuries until modern science began to re-examine the conventional linear model of time. What if, rather than a solitary Big Bang, the cosmos experiences an unending cycle of creation and destruction? Albert Einstein's 20th century theory of relativity fundamentally altered how we perceive space and time, prompting scientists to explore their interplay in the universe's evolution. Yet, a fundamental question persists. Is the universe truly in a state of perpetual flux, or does a hidden, cyclical pattern govern its destiny? The Big Bounce theory offers a compelling response to this inquiry. It's fascinating to realize that this concept is not entirely new, but is grounded in physical principles that have been validated in other areas, such as the physics of black holes. Though the link between these different ideas might initially seem weak, a closer look reveals that both the Big Bounce and black hole dynamics point toward a universe far more intricate than we typically assume. The shift in thinking from the Big Bang to the Big Bounce also encourages a profound reassessment of our concept of time. Instead of viewing time as a linear progression, perhaps it operates more like a wheel, turning endlessly through ages. This notion has stirred the creativity of many beyond the scientific community, with artists and philosophers alike delving into the idea of eternal cycles in their work, hinting that our lives could be a small part of a much more magnificent cosmic process. Why, you might ask, is it so crucial to investigate the origins of the Big Bounce? The significance lies in the understanding that each new theory we examine moves us one step closer to grasping the ultimate truth of our universe. Every discovery provides a fresh vantage point, challenging our established beliefs about the nature of reality. At its heart, this quest for knowledge is a journey to comprehend our own identity within this immense cosmos. With every turn of the cycle, the universe might undergo profound transformations, which raises questions about how these changes could impact matter, energy, and even life itself. The concept of the Big Bounce invites you to reflect deeply on our position in a cosmos that could be infinitely more ancient and complex than we can fathom. These cycles of expansion and collapse would shape not only the cosmic structure, but also the very essence of time and existence. Before we dive deeper into this theory, it's vital to acknowledge that every scientific model is met with its own set of challenges and critiques, as the scientific community never embraces an idea without exhaustive examination. Therefore, we must ask, what evidence actually supports the Big Bounce theory, and how it stands up when compared to other cosmological frameworks? These inquiries are essential for tracing the evolution of our cosmic understanding. Our search for answers about the Big Bounce propels us to explore the fundamental nature of the cosmos itself. As we venture further into this fascinating theory, it is crucial to remember that the acquisition of knowledge is a perpetual journey. There is no final stop, only a continuous path marked by surprising discoveries. Each question we dare to ask swings open new doors, beckoning us to continue our exploration into the unknown. When we look to the horizons of cosmology, we see that the Big Bounce is more than just a theory. It is a testament to our undying curiosity. It serves as a reminder that while our comprehension of the universe may evolve, our innate desire for knowledge is constant. This endeavor to understand the cosmos is, in the end, an endeavor to understand ourselves, bringing us incrementally closer to deciphering the mysteries of our past, present, and future. The idea of a cosmos locked in a repeating sequence of expansion and contraction, known as the Big Bounce, forces us to confront one of cosmology's most profound puzzles. Could the universe be fated to relive its own history infinitely? The cosmological cycle theory paints a striking picture where space and time are woven together in an eternal oscillation, much like the rhythmic rise and fall of ocean waves. But what would this truly signify for our perception of the cosmos and of ourselves? At the very core of the cosmological cycle theory is the proposition that the universe is not a singular occurrence, but rather an endless succession of cycles. You can visualize it as a balloon that inflates and subsequently deflates. In each phase, the universe might expand, becoming filled with stars, galaxies, and matter, only to inevitably shrink back to its primordial state, poised for the next cycle. But what cosmic forces could possibly be orchestrating these immense processes? Gravity, the fundamental force that binds the cosmos, assumes a central role in this cyclical drama. As the universe expands, gravity works as a cosmic brake, slowing down this outward rush. It is theorized that over vast stretches of time, gravity's influence could become dominant, compelling the universe to reverse course and begin contracting. Is it not captivating to consider that the same force enabling galaxies to drift apart could also be the very one that will ultimately draw them back together? As the universe contracts, its temperature and density escalate dramatically, creating an environment that would mirror the conditions just before the Big Bang. Picture the cosmos as a colossal pressure cooker, where heat and pressure intensify until a critical point is reached, triggering an explosive rebound into a new cycle of expansion. This bounce could potentially spawn entirely new universes, each endowed with its own distinct properties and characteristics. But, you might ask, are these universes genuinely unique, or do they follow recurring patterns? This notion of a cyclical cosmos also compels us to examine the principle of entropy, which, in simple terms, measures the level of disorder within a system. Some scientists propose that mechanisms might exist for the universe to reset its entropy with each new bounce, essentially wiping the slate clean for the next cycle, even as disorder naturally increases over time. Could this be the fundamental secret to a perpetually cycling universe? The implications of a cosmos that cyclically expands and contracts are truly profound, prompting a complete reassessment of our concept of time. Instead of perceiving time as a linear progression, we are invited to imagine it as a circle, where every cycle represents a fresh chance for both creation and destruction. This perspective naturally leads you to question how it might reshape our views on life and death, and whether the Big Bounce could provide an answer to humanity's timeless search for its cosmic significance. If the universe does indeed repeat itself, does that suggest our own lives might resonate through these cosmic iterations? It's possible that our actions, thoughts, and feelings are not as transient as we believe, but are instead intricately woven into the fabric of the cosmos in an eternal pattern. The theory of a cosmological cycle is not just a philosophical exercise. It rests on a solid mathematical foundation, with scientists developing models to describe how the universe might behave under such conditions. The question, however, is whether these models are robust enough to truly validate the idea. Observational data are also critical in this investigation, as certain studies have detected irregularities in the cosmic microwave background radiation that could suggest the universe has experienced prior cycles. Science is constantly evolving, and every new observation could move us closer to understanding the truth. The Big Bounce theory challenges you to think of time cyclically rather than linearly, and to contemplate how our personal experiences might fit into a far grander story. Within this cosmic ballet of expansion and contraction, we might uncover not just the destiny of the universe, but the very meaning of our existence. The history of the universe is undeniably a story of cycles, with each one presenting a new beginning. Gravity, one of the most fascinating forces we know, is fundamental to the dynamics of the cosmos and crucial for comprehending the behavior of our cyclical universe. Did you know that gravity's influence extends beyond simply pulling things together, to actually sculpting the very nature of space and time? This interaction is the engine that drives the universe's recurring expansion and contraction, forming the heart of the Big Bounce theory. Gravity functions as a cosmic conductor, directing the movements of galaxies, stars, and planets. While you might typically think of it as the force that makes an apple fall from a tree, its true nature is far more profound on the grand universal scale, where it shapes the fabric of spacetime itself. Picture a large trampoline. If you place a heavy object in its center, the surface bends and curves, causing smaller balls to roll toward it. In much the same way, the immense gravity of a star warps the space around it, guiding other celestial objects into its orbit.
The expansion of the universe that started with the Big Bang can be understood as a direct consequence of this curvature of spacetime. But what occurs when gravity's pull eventually overpowers the outward momentum of expansion? This is the moment where the big bounce cycle enters the picture, as gravity could theoretically force the universe to start contracting again. This process is much like inflating a balloon that later deflates when you stop blowing air into it. Could it be that we are currently living in an expansion phase that is ultimately destined for contraction? The notion that the cosmos might experience these cycles of expansion and contraction brings up some captivating questions, leading us to wonder if time itself is an endless loop rather than a straight line. Gravity also maintains a delicate balance among the forces governing the cosmos. Dark matter, an invisible substance we know exists, serves as a cosmic adhesive holding galaxies together. In contrast, dark energy, a mysterious force that is accelerating the universe's expansion, continues to be a puzzle. In the Big Bounce model, if gravity were to become the dominant force, it could trigger a contraction, with dark matter possibly holding everything together during this collapse.
Ultimately, the universe's journey through expansion and contraction forces you to contemplate the nature of existence. If the cosmos collapses into a state known as the Big Crunch, what becomes of all the matter and information it contains? Does it all vanish? Or is there some mechanism that allows energy and matter to be reborn in a new form in the subsequent cycle? This very dilemma challenges our most fundamental understanding of reality itself. In this context, gravity transcends its role as a mere physical force, raising philosophical questions about the ultimate destiny of the universe. It compels you to ask whether we are fated to an unending cycle of creation and destruction, or if a more profound meaning lies beneath this repeating process. Gravity, therefore, becomes a powerful symbol of duality, representing the tension between cosmic order and chaos, and between genesis and annihilation. Understanding how gravity steers a cyclical universe is central to the way scientists construct their cosmic models. The mathematical frameworks that describe these periods of expansion and contraction are incredibly complex, yet their fundamental purpose is to capture how gravity shapes these cosmic rhythms. These intricate models are absolutely essential for evaluating the scientific validity of the Big Bounce theory. Gravity also reveals the inherent fragility of cosmic structures. While expansion may propel some galaxies outward, others can become ensnared by their own gravitational pull, collapsing into much denser systems. This constant interplay of forces ultimately dictates the fate of galaxies and, by extension, the destiny of the entire universe, with some becoming relics of a contracting cosmos, while others experience perpetual expansion. This deep connection between gravity and the cosmic cycle serves as a reminder that everything in the cosmos is interconnected, despite its staggering scale. Every star, galaxy, and black hole contributes to this grand cosmic ballet. As you contemplate gravity and spacetime, you realize that each phase of expansion and contraction presents a new chance to learn about ourselves and our own position within the universe, where every mystery pushes us to explore reality more deeply. Have you ever considered what proof might exist to support the notion of cosmic cycles? The Big Bounce concept posits that our universe isn't a singular event, but just one phase within an infinite loop of expansion and contraction. To truly grasp this idea, it's vital to explore the observational evidence that could substantiate this captivating theory, starting with the cosmic microwave background, also known as relic radiation, which is the thermal energy that pervades the cosmos. Imagine the universe as a vast ocean of energy stretching across all of time.
In the instant of the Big Bang, the cosmos was incredibly hot and dense, and as it expanded, it cooled, which allowed light to finally break free and traverse space. This ancient light is what we now observe as the cosmic microwave background. By analyzing this radiation, scientists have identified patterns suggesting the universe has passed through multiple phases of expansion, much like the ripples that spread when you toss a stone into water. Dark matter introduces another critical element to this cosmic puzzle. Although it remains invisible to us, its existence is confirmed through its gravitational influence on the cosmos. You might think of it as feeling an unseen push in a park. Dark matter is an invisible force that helps shape the dynamics of cosmic expansion. Some scientists speculate that the interaction between dark matter and dark energy could hold clues to the universe's life cycle, possibly linking this unseen matter to the phases of contraction and expansion. The large-scale structures of the universe, such as massive clusters of galaxies, provide another line of evidence. These formations are not static, but are in a state of continuous motion and evolution. Some researchers have noted that the patterns in how galaxies cluster together and drift apart might point to a universe that behaves cyclically, like partners in a dance who alternate between coming together and moving away. Gravitational waves, which are ripples in the very fabric of spacetime, present another exciting path for discovery. Predicted by Einstein and finally detected in recent years, these waves could carry information about past cosmic events, like the formation of black holes or supernova explosions. It's possible they could even reveal insights into the cycles of expansion and contraction, acting as evidence of collisions and mergers in a universe that is cyclical rather than linear. Of course, the search for evidence is far from over, as the study of dark energy, the enigmatic force that appears to accelerate cosmic expansion, also fuels the debate. What if dark energy isn't a constant force, but one that fluctuates over time? Some theories propose that dark energy might behave differently during a phase of cosmic contraction. Ultimately, mathematical models of the Big Bounce provide a framework for analyzing all this data, but the core challenge lies in how well these theories align with what we can actually observe in the sky. Ultimately, the Big Bounce represents more than just a captivating theory. It acts as a doorway to far more profound questions. If the universe truly operates in cycles, what does that imply about us and our position within it? Are we simply experiencing one chapter in an endless cosmic story? The answers could fundamentally reshape our entire understanding of existence. While this field of research is still in its infancy, each new discovery edges us closer to deciphering the cosmos's past and future, inviting us to gaze at the stars and wonder what other revelations await. The universe is an immense stage upon which countless cosmic dramas play out. And to comprehend its behavior, we must use a special language, mathematics. The mathematical models of the Big Bounce are the instruments that enable us to articulate this perpetual cycle of cosmic growth and collapse. To make this tangible, picture a bouncing ball. Just before it rebounds, it compresses slightly. And it's remarkable to consider that the universe might behave similarly, but on a scale beyond imagination. Within this framework, the equations function like the score of a grand cosmic symphony. Every symbol and variable corresponds to an element of the universe's reality, from the force of gravity to the enigma of dark matter. As we arrange these elements, distinct patterns become visible, providing hints about the universe's fundamental nature. The formulas that describe the Big Bounce suggest that instead of a final, definitive end, the universe could be destined for an infinite series of rebirths. One of the central concepts in these models is the density of the universe. Imagine you are inflating and deflating a balloon, As it expands, the air density inside it changes. In the same way, the density of matter and energy in the universe alters as it expands. However, when this density reaches a crucial threshold, the magic of the Big Bounce is theorized to happen. At this precise moment, expansion halts, and the universe starts its journey of contraction, a process modeled by Einstein's equations of general relativity.
These pivotal equations give us the power to simulate the behavior of spacetime itself. By incorporating variables like energy and the curvature of space, scientists can forecast how the universe might react under various conditions. The aspiration behind these mathematical models is, in essence, to devise a formula capable of predicting the future of the cosmos. The Big Bounce is also intricately linked to entropy, which is a measure of disorder within a system. In a cyclical universe, although order appears to decay with each cycle, a process is always in place that allows the universe to begin anew, much like the cycles of life in nature, where fallen leaves decompose to enrich the soil for new growth in the spring. The true elegance of these mathematical models is their capacity to distill immense complexity into accessible narratives. Consider the motion of a swinging pendulum. With every arc, it reaches a peak before descending, an oscillation captured perfectly by simple equations. In a similar fashion, the universe is thought to oscillate between periods of expansion and contraction, and these cosmic pulsations can be expressed through the language of mathematics. This line of thinking introduces a captivating question. Could there be different kinds of big bounces? Some models propose that multiple versions of this cycle might exist, each determined by the unique initial conditions of its universe. It's as if every bounce is a new interpretation of the same cosmic melody, leading to an endless number of variations in this grand symphony, and raising the possibility that these alternate universes have their own stories to tell. As we delve into these models, it's natural to wonder how they connect to the reality we perceive. If the universe is indeed cyclical, does that render time an illusion, or is it merely a construct of our limited perception? While the mathematics of the Big Bounce may offer some answers, it also introduces new philosophical dilemmas that challenge our core understanding of time and space. Research in this domain is constantly advancing as scientists work to refine these equations, making them ever more precise. With each breakthrough in particle physics or cosmology potentially offering new clues. Have you ever considered how a colossal event like the Big Bang fits in with the concept of the Big Bounce? Initially, these two theories might appear to be at odds, but exploring their similarities and differences actually allows us to achieve a deeper comprehension of the universe. Let me walk you through this fascinating comparison. The Big Bang model, as most are aware, posits that the universe originated from an incredibly hot and dense singularity, approximately 13.8 billion years ago, and has been expanding ever since. Now, what if I were to tell you that the Big Bounce theory proposes something different? Instead of a single explosive beginning, it suggests that our universe might exist in a ceaseless rhythm of expansion and contraction. The essence of the Big Bounce can be visualized with a simple balloon. As you inflate it, it grows, but if you let the air out, it shrinks back down. This is the very cycle that may define the eternal life of our cosmos, where each end is merely the prelude to a new beginning. What if the Big Bang wasn't a singular event, but rather one phase in an endless series of cosmic expansions and contractions? The Big Bounce theory presents this exact possibility, not as a replacement for the Big Bang, but as a framework that contains it. This model proposes that our universe's origin was just one chapter in an immense history of cycles, prompting us to ask if countless Big Bangs could have occurred over eons. Embracing this concept forces you to reconsider the very nature of time, imagining it not as a linear arrow, but as a perpetual loop. Both theories, however, grapple with fundamental questions about matter and energy. The Big Bang model must account for their current distribution, whereas the Big Bounce must explain how energy is preserved across the immense transition from a contracting to an expanding universe. This leads to a profound question. Does cosmic energy get recycled, or is it eventually lost to the void?
Let's turn our attention to entropy, the principle that disorder within a closed system inevitably grows. According to the Big Bang theory, the universe's entropy has been relentlessly increasing since its inception. This creates a significant puzzle for the Big Bounce model, as ever-increasing entropy would seem to preclude infinite cycles. To solve this, some physicists propose a fascinating idea. Perhaps the universe's entropy is completely reset at the end of each contraction, clearing the slate for a fresh start.
Gravity, too, occupies a central position in both cosmological narratives. Within the Big Bang framework, gravity serves as the cosmic brake, gradually slowing down the expansion of the universe. In the Big Bounce model, however, gravity's role is far more dynamic. It first halts the expansion and then becomes the driving force that pulls everything back into a superdense state, setting the stage for the next bounce. This compels you to wonder if gravity is simply a participant in one cosmic era or the master architect of the entire cyclical drama.
Despite their elegance, both frameworks have their share of critiques. A major challenge for the Big Bounce is its testability. Since it describes events that precede our own observable universe, finding direct empirical evidence is incredibly difficult. This raises a crucial philosophical point. Can an untestable hypothesis ever be accepted as a legitimate scientific explanation? Furthermore, the Big Bounce doesn't entirely solve the mystery of origins, leaving you pondering the nature of the void between cycles. Is it a state of pure nothingness or something else entirely? Even with these hurdles, the Big Bounce has earned a significant place in contemporary cosmological debates. It challenges you to perceive our universe not as a one-time event, but as a single iteration in an eternal, self-perpetuating cycle, which in turn makes you reflect on your own place in this immense cosmic dance. Ultimately, the Big Bang and the Big Bounce provide distinct and powerful narratives about creation, and while they appear to be in opposition, they might actually represent two sides of a more complex cosmic truth. Engaging with these ideas does more than expand our knowledge of the cosmos. It forces us to confront fundamental questions about our own existence and the fabric of time. Comparing the Big Bang to the Big Bounce is an intellectual adventure into the very essence of reality. As we push the boundaries of discovery, maintaining an open mind is essential, because the true nature of the universe's cycle might be far more intricate and magnificent than we can currently comprehend. The concept of a cyclical cosmos raises thrilling questions about existence and time itself. Imagine a universe with no true beginning or end, one that perpetually repeats in an endless loop. While this may sound like a premise from science fiction, it's a topic at the forefront of serious cosmological inquiry. Considering a universe that expands and then contracts forces you to ask, is time a linear progression, or is it a circle that brings us back to familiar points? To delve into these ideas, we can turn to philosophy as our guide. If the universe is indeed cyclical, how does that alter your perception of time? We experience our lives as a straight line. We are born, we live, and we die. But in a repeating cosmos, this linear view gets complicated. death might not be an end, but merely a transition into the next cosmic iteration, a new chapter in an eternal story. The question for you is whether this notion brings a sense of peace or a profound sense of unease. This notion of cosmic cycles also makes you question the nature of causality itself. If the universe undergoes repeated expansions and contractions, is each new cycle a perfect replica of the last, or do variations arise? This directly challenges the concept of free will. If your life is fated to repeat exactly as before, are your choices truly your own? On the other hand, perhaps each cycle offers a chance to evolve, with every repetition becoming a slightly refined version of the one before it. In this cyclical vision of the cosmos, even entropy, the force of increasing disorder, takes on a new meaning. It might not be the universe's ultimate foe, but rather its constant partner in change. In a cosmos that continually renews itself, the question becomes how entropy is managed through each transition. Rather than an unstoppable march towards cosmic death, you could see entropy as a catalyst for transformation, with each universal reset providing a fresh path back to equilibrium.
Thinking about a cyclical universe also compels you to reconsider what it means to exist. If you are fated to relive your life over and over, what is the ultimate purpose of living? It's possible that accepting time as a cycle could lead to a deeper appreciation for every single moment. You might view each repetition not as a curse, but as another chance for learning, for growth, and for making things better.
But what if you find that, in spite of all your efforts, certain patterns in your life are incredibly hard to change? This line of thought expands into the philosophy of cycles, prompting us to question our connections with others. If every life is interwoven in a grand cosmic pattern, what kind of responsibility do we owe each other? Every choice you make could reverberate through these cycles, influencing not only your own existence, but the lives of everyone around you, reminding you of how profoundly your decisions shape the fabric of reality.
When you reflect on the ultimate fate of the universe, the concept of a cycle provides a completely different viewpoint. Rather than dreading the finality of an end, you can perceive it as the prelude to a new start. This prospect of rebirth can give you the courage to confront uncertainty head-on. In such a framework, death ceases to be an ending and instead becomes a profound transformation, challenging your entire understanding of spirituality and existence itself.
As you delve into these concepts, it's crucial to recognize that a cyclical universe is not merely a subject of physics. It beckons you toward an introspective journey where scientific inquiry and philosophical thought merge. How would your perspective on time and being shift if you accepted that everything you've ever known might occur again in an endless loop? This is an invitation to question your deepest beliefs and embrace novel ways of thinking. The idea of eternity is also central to this entire discussion. If the cosmos is cyclical, does that imply time stretches into infinity? Or is each cycle a finite, bounded era? Such questions compel you to contemplate your own mortality and the ultimate significance of your life within this vast context. A cyclical universe ultimately dissolves the clear lines between a beginning and an end, presenting you with a fresh lens through which to view your place in the cosmos. By confronting these immense questions, you might discover that life's true measure is not its length, but its depth and intensity. Each turn of the cosmic wheel could be a fresh chance for profound experience, learning, and love. From this perspective, the philosophy of the cosmic cycle urges you to treasure the present moment
and live with purpose, fully aware that every instant carries weight. Ultimately, the philosophical consequences of a cyclical universe are both deep and provocative, encouraging you to reconsider your perceptions of time, existence, and human connection. On this vast cosmic stage, entropy plays a fundamental role in the universe's narrative. But what precisely is entropy, and why is it so critically important to this story? You are invited to consider if, despite the repetition, there is always an opportunity for something new. Imagine you have a room that is perfectly tidy, with every object in its designated place. As you go about your life, things naturally become displaced and disorganized. This inevitable slide into disarray is a perfect illustration of entropy in action. In simple terms, entropy is the scientific measure of randomness or disorder within any given system. This concept becomes a central character when you discuss the universe and its potential cycles of rebirth. Within the Big Bounce model, the universe doesn't just expand, it also contracts. This raises a critical question. How does it handle all the disorder it has accumulated when it collapses back on itself? This is where the inquiry becomes truly captivating. Can the universe somehow reset its own entropy? Or is each successive cycle destined to be more chaotic than the one that came before it? To make this clearer, picture yourself tossing a beach ball into the air. Its ascent seems orderly and predictable, but once it starts to fall and bounce, its movements become scattered and chaotic. The universe's entropy can be viewed in a similar way. With each cycle of expansion and contraction, its behavior could grow increasingly complex. The essential question, then, is whether there is an ultimate limit to this escalating disorder. One of the most compelling theories proposes that the universe might have a mechanism for resetting its entropy during each contraction phase. This suggests that at the conclusion of every expansion, the cosmos shrinks to such an extreme degree that matter and energy are forced to completely reorganize. However, you have to ask if this is truly possible. Can the universe actually return to an ordered state after accumulating such a vast amount of chaos? Scientists speculate that this reset could take place in an incredibly hot, dense state, where the known laws of physics might behave in entirely unforeseen ways. The fate of entropy in those moments presents a fascinating puzzle that challenges our fundamental understanding of reality. If the cosmos can indeed wipe its slate clean, it implies that cosmic history is not linear, but cyclical and potentially eternal. While entropy generally increases during expansion, the extreme conditions of contraction might allow the universe to find a new equilibrium, though whether entropy can truly decrease remains a point of major debate. Most physicists maintain that, while moments of balance are possible, the total entropy of the universe relentlessly trends upward. Yet, what if the Big Bounce model holds the secret to managing this disorder across multiple cycles? Some theorists propose a radical idea that each new cycle could emerge with a different set of physical laws, allowing entropy to be contained or redistributed in novel ways. This concept opens a universe of possibilities, suggesting a cosmos designed to adapt and evolve through its own rebirths. The link between entropy and the Big Bounce also forces you to ask fascinating questions about time itself. Does time flow differently in each cycle, or is it a constant that simply repeats? If the universe resets, are you fated to live the same history over again, or does each iteration introduce new possibilities? It's vital to remember that entropy is not an isolated phenomenon. It is deeply connected to dark matter and dark energy, both of which are key players in the cosmic drama, influencing universal expansion and the steady accumulation of disorder. As you delve deeper into these cosmic mysteries, you may uncover truths that completely revolutionize your understanding of the universe. The idea of a cyclical cosmos, intrinsically linked to the concept of entropy, reaches beyond the boundaries of science and into philosophy, prompting you to question what it means to be a conscious being in a reality that might perpetually reset itself. This notion of a recurring existence challenges you to reevaluate your own place in the cosmos and the fundamental nature of life.
Within the Big Bounce theory, entropy transforms from a simple physical principle into a profound reminder of a dynamic, constantly evolving universe. Each new cycle of expansion and contraction could offer a completely fresh perspective, not only on matter and energy, but on your own history and significance. This endless cosmic rhythm of rebirth and decay is an invitation to ask fundamental questions and explore the very essence of your existence.
This leads you to wonder, what if your universe is not solitary, but is instead just one part of a vast multiverse, a theoretical ensemble of all possible realities? This captivating idea has long fascinated both scientists and philosophers. When you examine the Big Bounce, an intriguing possibility comes into focus. This very cycle of cosmic expansion and collapse could be the bridge connecting your reality to parallel universes. To better understand this, you can visualize the universe as an immense ocean, with each expansion cycle representing a single wave rising and falling. If the Big Bounce is a reality, then your universe's expansion might be just one of countless waves in an infinite sea of existence. In this context, every cycle could generate a new, coexisting parallel universe, complete with its own unique history and defining laws. While the concept of parallel universes is not new, the Big Bounce framework offers a fresh and compelling angle. It forces you to ask whether each cosmic rebirth creates an entirely new version of your reality. It is as if every wave breaking upon the shores of existence could sculpt a completely different coastline, with features and forms that never existed before. Some scientists even theorize that these parallel universes could influence one another in ways that are currently beyond your grasp. Could a single action in one reality create ripples in another? When you imagine an alternate you making a different choice at a critical moment, it leads you into the territory where empirical science and deep philosophical questions merge. The idea of a multiverse also compels you to reconsider the very nature of time. If the Big Bounce is real, time may not be a linear path, but a continuous loop, with each universal cycle representing a new beginning. Your entire perception of life would change if you knew that somewhere an alternative version of yourself is living out the consequences of every choice you never made. Dark matter and dark energy are central to this cosmic narrative, acting as the mysterious forces that shape your universe. You have to wonder, however, how these forces behave throughout the cycles of expansion and contraction. It is conceivable that they function differently in each new cycle, thereby creating universes with entirely distinct and unique physical properties. Contemplating the Big Bounce and the multiverse ultimately raises one of the most fundamental questions of all. What is the nature of reality itself? If there are infinite universes, each operating under its own laws of physics, then your understanding of the here and now becomes just one small part of a much richer and more complex existence than you have ever imagined. This concept of parallel worlds also carries significant ethical weight. If innumerable versions of you exist across these different realities, you have to consider how that affects the responsibility you have for your decisions. Every choice you make could be creating a new reality with its own set of consequences, turning morality into a far more intricate and profound subject.
Science is still working to untangle the connection between the Big Bounce and parallel universes. Certain mathematical models suggest that during a universe's contraction phase, theoretical tunnels through spacetime known as wormholes could form. These wormholes might allow matter and energy to transfer between cycles, and the search for evidence of such connections is set to become one of the great scientific challenges of our time. With every new discovery in cosmology, you move closer to understanding your place in the cosmos. The idea of a cyclical universe filled with parallel realities not only challenges your perception of the world, but also inspires you to reflect on the meaning of your own existence. If the Big Bounce is real, you may be part of a narrative far grander than you ever thought possible. The fascination with the multiverse stems from its scientific complexity as much as its power to ignite human creativity. From literature to film, the concept has become an endless source of stories and philosophical debates. This idea perpetually pushes you to question the reality you know and to imagine the limitless possibilities that could lie just beyond your perception. You may never uncover all the answers, but that doesn't diminish the importance of the search itself. Exploring the potential link between the Big Bounce and parallel universes drives you to question what you know and to imagine what could be. It is this powerful engine of human curiosity that will continue to propel you toward new frontiers of knowledge and understanding. The quest to comprehend the Big Bounce and its link to the multiverse serves as a powerful reminder that, while your life feels singular and straightforward, you are part of an immense sea of potential outcomes. Every new cycle of cosmic collapse and renewal could present a fresh chance to learn more about who we are and the universe we call home. As our exploration of these enigmas deepens, keep in mind that each question you pose brings you closer to illuminating the unknown. Suppose I suggested that the ultimate fate of the universe isn't as conclusive as you might believe. Most people picture cosmic collisions, perpetual expansion, or a frigid, desolate emptiness when they consider the end of everything. Yet the Big Bounce theory proposes an alternative, a future defined by an endless cycle of creation and recreation. Imagine a balloon that you can repeatedly inflate and deflate. This simple action serves as a metaphor for a cyclical universe, eternally oscillating between growth and collapse. In this model, expansion and contraction are not mere behaviors, but are fundamental to an eternal, repeating sequence. But if the universe does contract, what could possibly drive it to expand once more? The engine behind this process might be gravity, which acts as the central character in the cosmic drama. Its influence extends far beyond simply pulling objects together. It fundamentally dictates the large-scale conduct of the cosmos. As galaxies drift apart, a point could be reached where gravity's pull becomes overwhelming, initiating a universal collapse and leaving you to wonder, would that moment signify a final end or an entirely new start? For decades, scientists have explored the ramifications of a cosmos in perpetual motion. The notion that the universe could cycle between periods of growth and collapse introduces a vast range of new possibilities, prompting you to consider time not as a straight line, but as a recurring loop where the universe can reinvent itself. To verify this, astronomical observations are crucial. With increasingly sophisticated telescopes, we are identifying patterns within the cosmic microwave background, which is essentially a faint afterglow from the Big Bang. This relic radiation might hold the secrets to what occurred before our current expansion, suggesting that we could be living in just one phase of an ancient, ongoing process. Within this framework, you must also consider entropy, the scientific measure of a system's disorder, which becomes
a key factor. Entropy typically rises as the universe expands, but a contracting phase raises the question of whether a mechanism exists to reset this accumulation of disorder. Another critical element is dark energy, the enigmatic force driving the accelerated expansion of the cosmos. It's possible that this energy dictates the timing and nature of a potential contraction, transforming the simple balloon analogy into a far more intricate interplay between competing cosmic forces. The concept of a pulsating universe compels you to contemplate the very fabric of reality. An infinite series of cosmic cycles brings up deep inquiries about time and being. Do we exist on an endless loop, or on a linear path with no return? In a bouncing cosmos, each iteration might be a repetition, but it could also introduce variation and change. Some theories propose that matter and energy could undergo transformations beyond our current comprehension during these cycles, making you question whether the galaxies of a previous or future universe would be recognizable at all. This idea of a cosmic oscillation also has profound consequences for the meaning of life. If the universe undergoes endless cycles of destruction and renewal, you have to ask what part conscious entities play in this grand design. Are you just a passive observer of a repetitive celestial play, or does your existence hold a special significance that endures? This notion of cosmic recurrence resonates with many philosophical and spiritual beliefs, which often see nature as a constant process of change and rebirth. By studying these cosmic rhythms, perhaps you can gain deeper insight into yourself and your position in the universe. As you delve into these concepts, you discover a compelling paradox. While science and philosophy are often viewed as distinct domains of knowledge, the theory of an oscillating universe causes them to meet in a mutual pursuit of ultimate understanding. The notion of a bouncing cosmos might appear theoretical, but the inquiries it sparks are fundamentally human. Contemplating these cosmic cycles forces you to confront the deepest questions about being, time, and change, and to ask whether you are prepared to see the universe as being in a state of perpetual transformation, just like yourself. Within the immense theater of the cosmos, both dark matter and dark energy are central characters in the story of the Big Bounce. You can think of it as a celestial ballet where unseen influences direct the motions of every star and planet. This raises the critical questions of what these mysterious components truly are and how they shape the universe's cycle of expansion and collapse. You can conceive of dark matter as an apparition haunting the universe. While it is impossible to see or interact with directly, its existence is confirmed by its gravitational pull. This unseen substance is the cosmic glue that binds galaxies together and sculpts the overall architecture of the universe, preventing them from flying apart. Imagine the sensation of holding a magnet beneath the water's surface. You can perceive its force without seeing its source. This is an apt analogy for dark matter, whose powerful influence is felt throughout the cosmos, even as its true nature remains a mystery. Dark energy presents an even greater puzzle. Picture yourself inflating a balloon. As you exhale, it grows larger. But what if your breath didn't just push the balloon's surface outward, but actually made its expansion speed up? This is analogous to how dark energy operates in our universe, causing its expansion to accelerate. Scientists are deeply perplexed by this phenomenon, striving to understand its fundamental nature and where it comes from. So, you might wonder how these two elements connect to the Big Bounce concept. Within a cyclic cosmic model, both dark matter and dark energy could be the primary forces dictating the universe's behavior. As the cosmos contracts, dark matter could act as a scaffold, preserving the integrity of cosmic structures. Meanwhile, dark energy might be the trigger that dictates the precise moment of the rebound into a new expansion. creating a delicate equilibrium that permits the universe to be perpetually reborn. Entropy, too, has a significant part to play in this narrative. Consider an hourglass. The sand gradually trickles down, and once it is all collected at the bottom, the process begins anew with a simple flip. In the Big Bounce framework, entropy serves as a crucial variable that could govern how the universe's structures are assembled and reconfigured with each new cycle. While entropy grows during expansion, the contraction phase might allow for some of these structures to be fundamentally reshaped. A common question that arises is whether the universe can repeat this cycle forever. Prevailing theories propose that if dark matter and dark energy maintain their current behavior, the Big Bounce could indeed be an unending process. Yet an alternative perspective suggests that far into the future, these cosmic components might change their properties, which would fundamentally modify the life cycle of our universe. The mathematical frameworks that describe the interplay between dark matter and dark energy are incredibly sophisticated. At their heart, however, these models are designed to forecast how these forces will ultimately shape the cosmos's destiny. What if, at the conclusion of every cycle, the universe doesn't just expand again, but also undergoes unforeseen transformations? This leads us to question whether each cosmic rebirth is identical, or if every new cycle introduces entirely novel features. One fascinating idea is the potential for an enduring connection between dark matter and dark energy across all of universal history. Think of each cosmic cycle as a volume in a vast celestial library. With every reset, a fresh chapter begins, yet some fundamental elements carry over. What might these repeating cycles reveal about the essence of space and time? Delving into these concepts compels us to reevaluate our own existence. If the universe is truly cyclical, our lives could be just a brief instance in an endless series of cosmic rebirths, raising profound questions about our place in it all. Ultimately, the link between dark matter, dark energy, and the Big Bounce encourages a deep contemplation of the universe's true nature. Every new finding in this area broadens what we know, and also forces us to reconsider the very meaning of existence. As science progresses, our quest for answers to these age-old questions continues, leading us on an unending voyage through the immense and enigmatic cosmos. The real question is, are you prepared to accept a universe that is perpetually beginning again? This entire concept, suggesting our universe might experience repeated cycles of expansion and contraction, poses some captivating questions about the future. Let's begin by considering what the more immediate cosmic future could hold. Picture a scenario where, after eons of expansion, galaxies reverse course and start moving toward each other. As gravity's pull becomes dominant again, the vast, empty spaces between them would shrink, potentially ushering in an age of titanic galactic mergers, where familiar worlds could either combine or be completely obliterated. However, what if this isn't an ending at all, but simply the start of a new chapter? A number of scientists propose that following this contraction phase, the universe could arrive at a point of unimaginable density. From this state, a monumental bounce could happen, causing all of that compacted matter and energy to erupt outward once more. This raises profound questions about the consequences for time and cosmic history. If time itself is circular, could the events and experiences of our lives have already played out in some previous iteration? This notion of a cyclical future also reshapes how we view entropy, the second law of thermodynamics, which dictates that systems move toward greater disorder as energy spreads out. In a universe that expands forever, you would anticipate entropy to continuously rise, culminating in a final heat death. The Big Bounce model, however, presents a solution to this problem by proposing that entropy is reset with every cycle, enabling the universe to revert to a more ordered state at the dawn of each new epoch. This brings up the question of what roles dark matter and dark energy fulfill in this cosmic cycle. These enigmatic components, constituting about 95% of everything in the universe, could very well dictate its behavior during both expansion and contraction. If dark energy's outward push persists, could it somehow reverse itself, permitting gravity to once again become the dominant force? The dynamic between these forces might hold the secret to the universe's ultimate destiny. Another captivating element of the universe's future is the potential for entirely new phenomena to arise. Throughout these cycles of expansion and contraction, we could observe the creation of novel cosmic structures, and maybe even the appearance of new life forms on planets beyond our wildest imagination. It's impossible to know what marvels might await in a universe that is perpetually starting over. Despite the appeal of this cyclical viewpoint, not all scientists are convinced of its eternal nature. A significant question still lingers. Could there be a finite number of times the universe is able to bounce back? This uncertainty introduces a more sobering possibility, suggesting that even a cyclical cosmos might eventually face a final, irreversible end. Certain hypotheses propose that every new cosmic cycle could operate under a distinct set of physical principles, making each iteration fundamentally unique. This leads you to a profound question. Could the universe eventually reach a state from which it cannot rebound, trapping us in a final, irreversible cycle? Considering the universe's future also forces you to contemplate the place of consciousness within this grand cycle. If the cosmos is reborn time and again, could civilizations like your own also experience a form of rebirth? You could be part of an age of enlightenment, where the collective wisdom of prior cultures contributes to an everlasting inheritance, leaving you to wonder what lessons might be learned from their distant echoes. You cannot overlook the philosophical weight of these concepts. If the universe undergoes endless reinvention, how does that reshape your understanding of life and the passage of time? This idea of a perpetual cycle might alter the value you place on your experiences, heightening your sense of connection to the cosmos and reframing your life not as a straight line, but as a thread woven into a much larger cosmic tapestry. Of course, science is central to this entire conversation. You should know that predictions based on the Big Bounce model are not simple conjecture. They are grounded in extensive research and continuous observation. As your technology and telescopes become more powerful, every new finding potentially moves you closer to grasping your ultimate cosmic fate. This inherent curiosity about the cosmos compels both scientists and philosophers to delve into the meaning of a cyclical universe. As you uncover its secrets, the notion that you exist within an infinite loop provides a fresh perspective on your place in the grand scheme of things. It's vital, however, that you remain open-minded, as the Big Bounce is just one of many competing theories in modern cosmology. Every breakthrough reminds you that the universe is a vibrant, surprising place, filled with mysteries still waiting to be solved. The real question is, are you prepared to accept that your entire universe might be just one chapter in an even greater narrative? The quest to understand how the universe works has led to captivating theories, with the Big Bounce standing out as one of the most compelling. But you might ask what it would actually take to prove it. To grasp this, first think about how scientists piece together the universe's past. Peering into the cosmos is much like being a detective at a crime scene. You use powerful telescopes to analyze light from stars and galaxies that has journeyed for eons, carrying with it precious clues about cosmic history. So, what specific signals would you search for to validate the Big Bounce? A leading candidate is gravitational waves.
Picture the universe as a vast pond. When you toss in a stone, ripples spread across the surface. These cosmic ripples are the echoes of massive events, like black holes colliding. If the universe is truly cyclical, you might be able to detect unique patterns in these waves, a kind of cosmic whisper that hints at a history of repeated expansion and contraction.
You would also need to examine the cosmic microwave background, also known as relic radiation, which is the faint thermal afterglow that permeates all of space. Could this ancient echo also hold secrets about prior cosmic cycles? If the Big Bounce models are correct, you might discover subtle irregularities in this radiation, evidence that the universe didn't have a single origin, but has experienced numerous beginnings. This would be analogous to discovering multiple layers of old paint on a wall, each one telling the story of a previous renovation.
The vast structure of the universe itself offers another avenue for investigation. The way galaxies and their clusters are arranged across space reveals the history of cosmic expansion, and if the Big Bounce occurred, you would expect to see specific imprints left by each cycle on this arrangement. Furthermore, you must consider the roles of dark matter and dark energy. If the universe truly bounces, these enigmatic forces might behave in distinct ways during the phases of contraction and expansion, providing a key signature of the process.
You also have powerful computer simulations at your disposal, which allow researchers to build virtual universes based on mathematical models. By testing how a Big Bounce scenario unfolds, you can see if it leads to a cosmos that resembles the one you observe today. Yet, you must acknowledge the immense challenges. Finding definitive proof is exceptionally difficult, which is why a significant portion of the scientific community maintains a healthy dose of skepticism about the entire idea. So what then would convince a skeptic? Often the most persuasive evidence arises from discoveries you never anticipated. You have to remember that science is a constantly evolving journey, where revolutionary concepts can spring from data that once appeared trivial. It's much like an archaeologist unearthing a single artifact that completely redefines our understanding of a lost culture. In science, too, a seemingly small finding can change everything. Every new astronomical breakthrough is significant, as it could hold the key to a more profound understanding of the universe. International cooperation is also fundamental in this search for answers, with telescopes and observatories across the globe combining their data and resources to probe the cosmos. You can imagine this as a team of scientists from various fields uniting their expertise to solve a highly complex puzzle, where each new piece helps bring the complete picture into sharper focus. As we continue this pursuit, it is crucial to remember that knowledge is an ongoing journey, not a final destination. The Big Bounce theory, as captivating as it is, remains under development and requires a great deal of further research. Our curiosity and passion for understanding the cosmos are what drive us to keep exploring, asking new questions, and searching for answers. The future of this research will undoubtedly be shaped by a blend of creativity, technology, and collaboration, bringing us progressively closer to uncovering the universe's secrets and its potential cyclical nature. General relativity, the theory formulated by Albert Einstein in the early 20th century, completely transformed our comprehension of space and time. But what is the connection between this theory and the concept of a Big Bounce? Let's explore this remarkable link. General relativity explains that gravity is not simply a force that acts across a distance, but rather the curvature of space-time itself, which is caused by mass. Picture space-time as a vast, flexible fabric. The more massive an object placed on it, the deeper the fabric sags, creating the curvature we experience as gravity. Now, if we apply this principle to the entire universe, general relativity implies that our cosmos is not a static object, but a dynamic system in constant motion. So, what if instead of a single Big Bang followed by an unending expansion, the universe actually cycles through phases of growth and collapse?
This idea is the very essence of the Big Bounce. The concept suggests that after every period of expansion, the universe contracts and collapses inward, only to erupt once more in a new expansion phase.
As the universe expands, general relativity also indicates that its matter and energy content directly affect the curvature of spacetime. This is particularly important because dark matter and dark energy, which make up most of our cosmos, play a decisive role in spacetime's behavior. Should dark energy remain the dominant force, we might be headed for a future of infinite expansion. However, if the conditions are right, gravity could eventually overcome dark energy, leading to the ultimate collapse of the universe. General relativity provides the mathematical tools to describe such a collapse. As the universe contracts, the curvature of spacetime would grow to an extreme degree, and it's at this point that Einstein's equations become truly fascinating. At the moment of maximum contraction, it's theorized that all the physical laws we know might cease to apply. Since general relativity cannot give us definitive answers about what happens inside this singularity, it leaves the door open for entirely new theories to emerge. Even more compelling is the notion that, after this collapse, the universe could rebound and start a new cycle. How could this bounce occur? Some theories propose that the conditions at the core of the singularity might enable a transition to a new state of the universe, one where the fundamental properties of spacetime are transformed. In this light, the Big Bounce offers a unique viewpoint on the cyclical nature of time and space, inviting you to rethink what we consider the beginning and end of everything. Within the Big Bounce theory, the principles of general relativity are supplemented by concepts from quantum mechanics. This combination is absolutely essential because quantum mechanics governs interactions at the smallest scales, where subatomic particles act in ways that defy our everyday intuition. By merging these two powerful theories, scientists aim to understand not just how the universe behaves on a large scale, but also what happens under the extreme density and temperature where the two realms intersect. The search for a unified model that marries these two theories represents one of the greatest challenges in modern physics. A successful model would be incredibly relevant to the Big Bounce, as it could provide a much clearer picture of how the cycles of expansion and contraction take place, and what laws govern the universe at these critical junctures. Furthermore, it could offer solutions to fundamental questions about the very fabric of time and space. However, achieving this is far from simple. General relativity itself has faced criticism and challenges, especially when applied to extreme situations like those proposed in the Big Bounce. Singularities, points where density becomes infinite, are precisely where our current theories fail. But this doesn't mean we stop exploring. On the contrary, each problem presents a new invitation to seek deeper and more complete answers. An exciting aspect of the Big Bounce is the possibility that the universe has no definitive beginning or end, but rather exists in an eternal cycle. Consider the philosophical implications if the universe truly repeats itself infinitely. How might that change your understanding of life, death, and time itself? By offering a framework for comprehending spacetime, general relativity raises profound questions about the nature of existence, and its connection to the Big Bounce invites all of us to reflect on our place in the cosmos. The concept of a cyclical universe does more than just shift our scientific perspective. It also invites deep philosophical inquiry. Are we caught in an unending sequence, or is there some underlying meaning to each phase of expansion and collapse? These questions are as immense as the cosmos itself. The next time you gaze at the night sky, consider that every star and galaxy is on a cosmic journey that might be defined by infinite cycles of creation and destruction.
with general relativity and the Big Bounce serving as our guides to exploring this profound mystery.
At the heart of this exploration is quantum cosmology, a captivating field where two cornerstones of physics, quantum mechanics and general relativity, converge. To grasp how these two theories connect within the framework of the Big Bounce, you must first understand how each one portrays the universe. General relativity, formulated by Albert Einstein, provides a large-scale vision where gravity warps the very fabric of space and time. In contrast, quantum mechanics focuses on the bizarre behaviors of particles at the smallest subatomic levels.
The most compelling challenge arises when we consider the Big Bounce. What happens at the precise moment before the universe expands or after it collapses? This is exactly where quantum cosmology enters the picture. Think of the universe as an enormous balloon that first inflates, causing every point on its surface to move away from the others. But what if, instead of expanding forever, this balloon starts to deflate, contracting until the laws of quantum mechanics begin to dictate how energy and particles behave within it? Could quantum mechanics offer an explanation for how the cosmos transitions from a state of contraction to one of expansion? The answer appears to be a resounding and exciting yes. Researchers propose that during the final moments of contraction, quantum fluctuations could generate entirely new conditions that enable the bounce, permitting the universe to expand once more in a fresh cycle. It's as if, at the critical point of maximum density, particles engage in a cosmic game of hide-and-seek, arranging themselves into a new configuration that sparks a new beginning. A foundational idea at this intersection of quantum theory and the Big Bounce is the nature of the quantum vacuum. We typically imagine a vacuum as pure emptiness, but according to quantum mechanics, it is teeming with potential energy. This vacuum is like a vast ocean of possibilities, where particles can spontaneously appear and vanish. During the universe's contraction phase, this quantum vacuum might just be the spark needed to ignite the next cycle of expansion.
This idea of a cyclical universe also forces us to reconsider the nature of time itself. Within quantum mechanics, time is not necessarily a linear progression, which suggests that in a cyclical cosmos, it might function more like a circle than a straight line. If this is true, what would be the implications for our understanding of life and existence? Perhaps time is not merely a resource that runs out, but rather an experience that repeats, with each new cycle offering fresh opportunities for learning and discovery. While scientists employ intricate mathematical frameworks to investigate these ideas, you don't need to be an expert in mathematics to appreciate the marvels that emerge from this fusion of theories. For instance, by observing how particles behave under extreme conditions, such as deep inside a star or at the moment of the Big Bounce, physicists can develop predictions for how the universe might evolve throughout its future cycles. So, you might ask, why is this connection between quantum mechanics and the Big Bounce so significant? Unraveling how these two theories are interwoven not only helps us solve the great mysteries of the universe, but could also unveil fundamental aspects about the nature of reality itself. If quantum mechanics is indeed a key player in the cosmic cycle, then our conventional views of time, matter, and energy may be far more interconnected than we currently assume. As researchers continue to explore and refine their mathematical models, it becomes increasingly apparent that the Big Bounce is more than just a fascinating hypothesis. It could be a crucial key to understanding the deeper mechanics of the cosmos. And although there is still an immense amount to uncover, every single advancement moves us one step closer to comprehending how the universe may be fated to be reborn over and over again. In this light, quantum cosmology compels us to revisit our most fundamental questions. Is the universe
simply a stage on which we exist? Or are we an integral part of a much larger cycle that transcends our present understanding? The notion of a cyclical cosmos, where every end is merely a new beginning, challenges us to completely rethink our relationship with both time and our own existence. The union of quantum mechanics with the Big Bounce theory opens a gateway to countless possibilities that ignite both curiosity and a sense of wonder. It reminds us that the universe is a place brimming with secrets, where each revelation can lead to an even more profound question. The journey toward knowledge is every bit as thrilling as the destination itself, and through quantum cosmology, we are moving toward a richer, more complex vision of the universe we inhabit. However, the Big Bounce theory remains a subject of considerable debate within the scientific community, and not everyone subscribes to this idea. To fully appreciate its place in modern science, it is vital to examine the criticisms and obstacles that confront this compelling theory. One of the most frequent objections is that the Big Bounce is built upon mathematical models that are still very much in the developmental stage and far from complete. The mathematical framework supporting this theory is incredibly intricate, and many feel it isn't yet solid enough to provide a complete picture of the cosmos. What this really means is that some experts contend the Big Bounce is a precarious idea without a thoroughly developed and verified mathematical basis. Is it reasonable to embrace a theory that still lacks a definitive formula? Compounding this issue is the absence of unambiguous observational data, which presents another significant hurdle. While certain indicators hint at the possibility of a cyclical universe, a large portion of the scientific community finds the existing evidence too weak to offer conclusive support. How can you accept a concept when there is no definitive proof to back it up? Critics often assert that until compelling evidence emerges to the contrary, the Big Bang model rightfully holds its place as the most widely accepted explanation for the universe's beginnings. Another major point of contention involves entropy. The Big Bounce model posits that the universe can cycle through phases of expansion and contraction without endlessly accumulating entropy. This directly challenges the second law of thermodynamics, which states that entropy within a closed system naturally increases over time. This creates a compelling paradox. How can the universe revert to its original state without defying such a fundamental law of physics? For many skeptics, this contradiction represents one of the theory's most profound weaknesses. Then you have the problem of quantum gravity. For the Big Bounce theory to work, it must successfully merge general relativity, which explains gravity on a cosmic scale, with quantum mechanics, the set of rules that governs the subatomic realm. The absence of a unified theory that elegantly combines these two domains leaves a host of unresolved questions. How is it possible for an incomplete theory to accurately describe the behavior of the entire universe? This lack of a cohesive model is a substantial obstacle that prevents the Big Bounce from gaining broader acceptance among physicists. Criticism also arises from the existence of competing models. You see, there are numerous theories that try to account for the origin and evolution of the universe. Some, like the theory of cosmic inflation, present alternative explanations that many find simpler or more elegant. So, what is it that makes the Big Bounce a more attractive option than these other ideas? While proponents argue that its cyclical nature resolves certain issues that plague more conventional models, it faces stiff competition in the theoretical arena. Public perception also significantly influences this debate. The narrative of the Big Bang has been so widely circulated and embraced that it has become an integral part of our popular culture. The Big Bounce, on the other hand, remains a comparatively new and less familiar concept for most people. How does this disparity impact its potential for acceptance? Familiarity can be a potent force in the adoption of scientific principles, and the Big Bounce has a considerable journey ahead before it can achieve the same level of recognition and understanding as the Big Bang.
The difficulties certainly don't stop there. The sheer complexity of the simulations required to model a cyclical universe is immense. Scientists are forced to contend with a multitude of variables and initial conditions, any of which could dramatically change the outcome. Are our current computational capabilities even powerful enough for such a task? The answer to that question could very well decide whether the Big Bounce eventually becomes a mainstream theory or lingers as a concept struggling to secure its footing in the vast expanse of cosmology. Within the academic sphere, the absence of a unified consensus is another critical factor. Scientists frequently align themselves with different schools of thought, with each group championing its own theories and methodologies. This division can seriously impede the path to acceptance for a novel idea like the Big Bounce. How can any theory truly flourish if there's no agreement among the experts in the field? While collaboration and open dialogue are essential for progress, science, like any human endeavor, can sometimes become mired in disputes and rivalries. We also cannot overlook the impact of funding on scientific research. The way resources are distributed can effectively dictate which theories get explored and which are left on the back burner. If the Big Bounce fails to attract the necessary financial backing, its development could be severely constrained. Is the scientific community prepared to invest heavily in a theory that doesn't yet rest on a firm foundation? This is a serious predicament that could ultimately slow our progress in understanding the universe. Ultimately, science is a process of constant evolution. Theories are proposed, challenged, and sometimes discarded. While the Big Bounce faces numerous obstacles, it also presents new opportunities for discovery. It's possible that in the future, as our knowledge of the cosmos deepens, this theory will find its proper place within the grand puzzle of existence. The answer might be closer than you imagine. For now, the Big Bounce continues to be a subject of intense and fascinating exploration. The Big Bounce is a concept that, despite its origins in cosmology, has permeated popular culture in some remarkable ways. But you might wonder how a scientific theory can come to shape movies, novels, and television shows. The explanation is rooted in our shared, innate fascination with the origin and ultimate fate of the universe. The very notion that the cosmos could be caught in an endless cycle of expansion and collapse ignites our imagination and beckons us to contemplate the great unknown. Just think about the widespread appeal of science fiction. Narratives like those in Interstellar or even the show The Big Bang Theory have enthralled millions of viewers. But have you ever considered how these stories connect to the idea of the Big Bounce? The concept of a cyclical universe gives writers the freedom to experiment with time as a nonlinear structure. In place of a singular beginning and a final end, you have an eternal loop where every conclusion marks a fresh start. This fundamentally alters how characters and plot lines can unfold, lending them new layers of depth and complexity. In literature, you'll find that authors such as Kurt Vonnegut have employed cosmic concepts to delve into the nature of existence and destiny. In his novel, Cat's Cradle, for instance, the idea is floated that reality itself is just a game of chance within a universe that endlessly repeats. This interplay between fiction and science is not merely a coincidence. It mirrors humanity's unending quest to comprehend our own place in the vastness of space. Even in the world of video games, titles like No Man's Sky have woven the idea of a cyclical universe directly into the player's journey. In certain video games, you can navigate procedurally generated galaxies, where every celestial body is locked in a perpetual cycle. This ability to travel through a self-renewing universe encourages you to contemplate the boundlessness of space and time. It's a fascinating thought that within a cyclical cosmos, each of your adventures might be a reinterpretation of an ancient narrative, just with a novel twist. Television series have also powerfully adopted this motif, with shows like Dark centering on time travel and recurring loops to demonstrate how past actions can reshape the future in unforeseen ways. This storytelling method is not only entertaining, but also prompts you to reconsider the linear nature of time and the true weight of your own choices. The link between the Big Bounce theory and these narratives becomes unmistakable, as both invite you to investigate the intricate fabric of time and existence. In the realm of cinema, films such as Donnie Darko delve into concepts of parallel universes and temporal loops. Through their captivating plots, you are confronted with the notion that your destinies could be intertwined in ways that currently elude your understanding. This concept clearly echoes the Big Bounce, in which the conclusion of one universe could signify the birth of another, resonating profoundly with how we perceive life and mortality. But what makes these ideas so utterly compelling? The answer could be rooted in the deep uncertainty that surrounds our own future. You inhabit a world where definitive answers to the fundamental questions of life, death, and the universe are often just out of reach. The Big Bounce presents a vision implying that while everything may appear to conclude, you are actually part of a continuous process of renewal, which can be a source of great comfort. Music, too, has drawn inspiration from these profound concepts, with artists and composers crafting works that mirror the idea of cycles and rebirth. Songs that touch upon reincarnation or fresh starts strike a chord with those of you searching for meaning within repetition. The recurring melodies and lyrics can be interpreted as a metaphor for the Big Bounce, where every note is an echo from a universe embarking on a new journey. We should also acknowledge the documentary films that have examined the subject of cosmology in an approachable manner. Productions that lucidly explain the Big Bounce have introduced these ideas to a much broader audience, helping to demystify science and increase its accessibility. These visual stories encourage reflection and discussion, proving that an interest in the cosmos extends far beyond the scientific community. It is a universal human curiosity. As you explore these connections between science and culture, it becomes evident that the Big Bounce is far more than a simple cosmological theory. It stands as a wellspring of inspiration. It beckons you to imagine a universe that is perpetually renewing itself, a notion reflected in your own lives, where every ending can serve as a prelude to a new beginning. In a world that often feels chaotic and unpredictable, the idea of cycles can provide a comforting sense of continuity and hope. The concept of a cyclical universe where everything recurs in a limitless pattern might sound like it was pulled from a science fiction novel, yet it holds deep significance for your understanding of reality. What if your very perception of time and the cosmos is mistaken? Instead of seeing time as a straight line extending infinitely forward, imagine it as a vast, continuous circle. This shift in perspective could revolutionize not only your comprehension of the universe, but also your own role within it. Evidence of cycles is abundant in nature, from the transition of the seasons to the life cycles of stars, reminding you that our planet is in a state of constant renewal. This understanding can prompt you to see your personal struggles and challenges not as finalities, but as integral parts of a larger cycle that ultimately moves you forward. Each joy and sorrow you experience might just be another turn in the great spiral of time. Considering that the universe may have undergone numerous cycles of expansion and contraction, leads to a compelling question about what the future holds. The Big Bounce theory proposes that while the current universe is expanding, it will one day halt and begin to contract. This notion may sound intimidating, but it can also be incredibly freeing. If everything is part of a cycle, then your present difficulties are merely a temporary phase in a much grander process, potentially reframing death not as an absolute end, but as a simple transition to another state of being. Viewed this way, death ceases to be a dark void,
and instead becomes a threshold into the next phase of an ongoing loop. This idea of a cyclical universe compels you to reconsider the very definition of time. In a reality where all things repeat, can time truly be the linear progression we perceive it to be? It's possible that time is more akin to a spiral, where each rotation returns you to the same season, but with a greater depth of experience and insight. A perspective that could transform how you appreciate every moment.
The notion of cycles also resonates deeply with our emotions and personal connections. Much like the cosmos, your own life is characterized by periods of growth and decline. Joy can emerge from sorrow, just as connection can replace loneliness. By recognizing the cyclical pattern of your experiences, you can learn to navigate difficult times with acceptance, understanding they are merely a part of a larger developmental process. A cyclical universe can also foster a more profound relationship with your surroundings. If everything is intertwined in an unending loop, your actions resonate far beyond their immediate consequences. Every choice you make sends ripples through the very structure of reality. This raises the question of how you can live with greater mindfulness and responsibility, fully aware of your role within this magnificent cosmic cycle. Furthermore, the implications of a cyclical cosmos can enrich your understanding of spirituality. As you delve into these concepts, you might uncover a more profound sense of purpose. The realization that every life and every experience contributes to an infinite cycle can inspire you to place greater value on your interactions and what you contribute to the world. It prompts the question, what kind of legacy do you wish to imprint upon this turn of the wheel? Ultimately, contemplating a universe that endlessly renews itself creates a space for optimism. If the cosmos is destined for rebirth time and again, the potential for renewal and transformation is ever present. This can serve as a powerful reassurance that even in the bleakest of times, the possibility of a fresh start always exists. This entire concept encourages you to see the elegance in life's patterns, knowing that every conclusion is simultaneously a new commencement. Now, what would you think if I proposed that the universe behaves like a colossal wave, endlessly rising and cresting, only to fall and begin again? Our journey into the Big Bounce theory has explored the captivating possibilities of a cyclical cosmos, where expansions and contractions are not singular events, but phases in an infinite sequence. This idea not only invites you to reflect on the nature of the universe, but also forces you to re-examine your own existence and the very fabric of time. In a universe that is perpetually restarting, what is the significance of a single life? Should the Big Bounce prove to be true, your entire conception of time might need to be revised. Instead of a straight line extending from the past into the future, you could envision time as a circle, where every ending marks a new beginning. Isn't it a breathtaking thought that each one of us might have already lived in a universe that existed before our own? As you explore the concept of a cyclical universe, significant questions begin to surface, particularly regarding entropy. In our current cosmos, entropy is constantly increasing, pointing toward an eventual state of equilibrium, often called the heat death of the universe. The Big Bounce model, however, suggests entropy could be managed differently. Perhaps each new cycle is initiated with a complete reset of entropy, which would permit life to emerge and thrive in every new iteration. The philosophical ramifications of the Big Bounce are equally powerful. If the universe is in a constant state of renewal, how should that knowledge shape your perception of life, death, and meaning? Could it be that your actions within this particular cycle will carry consequences that ripple into future cycles?
The idea that each of us might experience numerous lives at various stages of development could fundamentally alter how you choose to live right now. When you consider the future of the cosmos through the lens of the Big Bounce, a vast horizon of possibilities opens up. In place of a definitive, apocalyptic conclusion, you can entertain the notion of eternal rebirth. This vision of the future, filled with endless cycles of creation and destruction, can be a profound source of hope. In this context, the Big Bounce prompts you to consider how your present actions might help shape the universe that will follow.
Science, of course, holds a vital role in this discussion. With every technological leap, new observations and experiments can bring you closer to a more concrete understanding of a cyclical universe. Unanswered questions about observable phenomena, like the cosmic microwave background or the nature of dark matter, continue to drive exploration. What incredible discoveries are waiting for you in the years ahead? Will you ever be able to witness one of these cosmic cycles in progress? You should not disregard the criticisms and challenges that the Big Bounce theory currently faces. Every scientific model encounters skepticism, and it is precisely this critical scrutiny that fuels advancement. As scientists persist in their investigations and debates, your collective comprehension of the cosmos evolves. The Big Bounce thus becomes a testament to human curiosity, a powerful reminder that there is always more to learn and discover. So, how can you apply the lessons of the Big Bounce to your own daily life? The fundamental concept of cycles can teach you to better appreciate life's alternating peaks and valleys. Each hardship can be viewed as a period of contraction that precedes a new expansion, serving as a reminder that light always follows darkness. Resilience becomes your greatest asset, enabling you to gracefully navigate the recurring patterns of existence. This serves as a powerful reminder of how science and art can merge in extraordinary ways, fueling our shared imagination. You can see that within every cycle of the universe, a unique story is waiting to be told. Each cosmic era, from the explosive origin of the Big Bang to the theoretical Big Bounce, is saturated with profound mystery and a deep sense of awe. Questions about your own role within this immense cosmic drama will inevitably surface, compelling you to search for truths that lie beyond the limits of your perception. As you engage in this exploration, you nourish the very curiosity that propels humanity forward. The Big Bounce, in this context, transcends being a mere scientific theory and becomes a catalyst for meditating on the nature of your own existence. This concept challenges you to rethink your perceptions of time, space, and your fundamental connection to the cosmos. Each one of you is an integral component of this perpetual, unending cycle. And even though you may not possess every answer, the true significance lies in the voyage of discovery you undertake in your pursuit of understanding. So, as we bring our discussion on the Big Bounce to a close, keep in mind that every conclusion is merely the start of a new chapter. The universe, with its staggering scale and intricacy, never ceases to inspire astonishment. Much like the ocean's waves that endlessly return to the coast, you may find that your deepest questions and searches will circle back to you, time and again, throughout each phase of existence.